Good day, math learners! Today, we will continue discussing on function, particularly on the inverse function. For this video, we will be dealing on inverse function, including its basic concepts, one-to-one function, and composition. Our objectives that you are going to recall on the basic concepts of a function, identify the inverse of a one-to-one function, define inverse function, find the inverse of a function, and verify if the pairs of functions are inverses of each other. So let's review. When we say function, it is a relation which describes that there should be only one output for each input. It is also a special kind of relation which follows a rule, meaning in any given x, there is only one y that can be paired with x, or no two ordered pairs have the same abscissa. For example, this set of coordinate points is considered as function because no two ordered pairs have the same abscissa. And take note as well, all functions are relations, but not all relations are functions. In a function, we consider the domain and the range. When we say domain, it is a collection of the first values in the ordered pairs, or the set of all input of x values. When we say also range, it is a collection of the second values in the ordered pairs, or the set of all output of y values. For example, this set of ordered pairs, the domain or the x values here are 1, 2, 3, 4, and 5. And for the range or the y values are 1, 4, 9, 16, and 25. So we have to focus on this inverse function. When we say inverse function or anti-function, it is a function that reverses another function. The inverse of a function is a set of ordered pairs formed by reversing the coordinates of each ordered pair of the function. The domain of the inverse function is the range of the function, and the range of the inverse function is the domain of the function. This notation can be read as f inverse of x. For example, these illustrations, particularly in figure 1, the first set consists of a, b, and c, and the second set consists of 1, 2, and 3. This is a function because no two ordered pairs have the same abscissa, and the mapping is considered as one-to-one correspondence. Therefore, the coordinates of this function are a and 3, b and 1, c and 2. For the figure 2, the first set, which consists of 1, 2, and 3, were the second set in figure 1. The second set, which consists of a, b, and c, were the first set in figure 1. This process is called the inverse function, in which the domain of the inverse function is the range of the function, and the range of the inverse function is the domain of the function. Therefore, the coordinates of f inverse of x are 3 and a, 1 and b, 2 and c. Another example for the inverse function. If we have function of 2x, its domain is 1, 2, 3, 4, and 5, then the expected range is 2, 4, 6, 8, and 10, because when we use the values of x in a given function, this will be the result. For example, substitute the value of x, which is 1, in the function 2x, and the result is 2, which is the value of our y. Substitute the value of x, which is 2, in the function 2x, and the result is, yes, 4, which is the value of y. Substitute the value of x, which is 3, in the function 2x, and the result is 6, which is the value of y, and so on. So the domain and range of the function can be represented by a set of ordered pairs as follows. So we have 1 and 2, 2 and 4, 3 and 6, 4 and 8, and 5 and 10. So this is the function of 2x. We have also the inverse function of the given 2x. We have 1/2 x or x over 2, because according to the definition of inverse function, that the domain of the inverse function is the range of the function, and the range of the inverse function is the domain of the function. And also, when you are going to substitute the value of x, which is 2, in the inverse function 1/2 x, its result is 1, because 1/2 of 2 is 1. When you're going to substitute the value of x, which is 4, in the inverse function 1/2 x, its result is 2, because 1/2 of 4 is 2. When you substitute the value of x, which is 6, in the inverse function 1/2 x, its result is 3, because 1/2 of 6 is 3, and so on. Therefore, the coordinates of f inverse of x is equal to 1/2 x are 2 and 1, 4 and 2, 6 and 3, 8 and 4, and 10 and 5. Please take note that the notation f inverse of x is not equal to this notation, which certainly denotes the multiplicative inverse of the function and has nothing to do with the inverse function of the given function. From the definition of the inverse function, it is equal to 1/2 x according to the given function, and the equivalent expression of the multiplicative inverse of the function 2x is equal to 1 over 2x. Therefore, they are not equal. From the definition of an inverse function, we observe the following properties. If f inverse of x exists, then f inverse of x is a one-to-one function. The domain of f inverse of x is equal to the range of f of x. The range of f inverse of x, it is equal to the domain of f of x. A function has an inverse if and only if the function is one-to-one function. That is one of the properties of our inverse function. Injective function, also known as injection or one-to-one function, is a function that maps distinct elements of its domain to distinct elements of its range. If a function is increasing throughout its domain or decreasing throughout its domain, then the function is considered as a one-to-one function. This example considered as one-to-one because distinct elements of its domain, which is the first set, maps to distinct elements of its range, which is the second set. The second example shows not a one-to-one. Please take note, class, that every element of the function's range is the image of at most one element of its domain. The term one-to-one function must not be confused with one-to-one correspondence, which are functions that each element in the range is an image of exactly one element in the domain. When we say horizontal line test, it is a method that can determine whether a given function has an inverse, but more importantly, to find out if the inverse is also a function. If the horizontal line intersects the graph of a function in all places at exactly one point, then the given function should have an inverse that is also a function. Again, a graph of a function is the graph of a one-to-one function if any horizontal line intersects the graph in at most one point. In this illustration, the function x squared plus 1 is formed a parabola. As you can see, we use the horizontal line to test if this given function has an inverse function. But there are 2 points on the graph intersects the horizontal line. So this function is not one-to-one function because in the horizontal line test, there must be exactly 1 point as the intersection of the graph and the horizontal line. Therefore, this g of x equals x squared plus 1. Its inverse is not a function. In the second illustration, the function g of x equals x squared plus 1 has a restriction where x is greater than or equal to 0 so that it will pass to the horizontal line test. If a function is not one-to-one, it is often the case that we can restrict the domain in such a way that the resulting graph is one-to-one. So those are the things that we have to consider in identifying the inverse function of the given function. So this time, we will be finding the inverse of a one-to-one function in which we will do the computation to get the inverse function of the given function. Here are the steps in finding the inverse of a function. First, you're going to replace f of x with y. Then, interchange x and y in the equation. So you have to replace every x with a y and replace every y with an x. Solve for y in terms of x. And lastly, replace y with this notation f inverse of x. For example number 1, find the inverse of f of x equals 2x. Here are the solutions. You are going to copy the given function and then replace f of x with y and it will become y equals 2x. After that, interchange x and y. Replace every x with a y and replace every y with an x. So our equation becomes x is equal to 2y. Then solve for y in terms of x. So we are going to transpose 2y to the other side of the equation and x to the other side of the equation because we need to isolate the variable y. So we are going to divide both sides of the equation by -2 and it will become x over 2. And after that, replace y with this notation f inverse of x equals x of over 2. Therefore, the inverse of the function 2x is x over 2. For example number 2, find the inverse of the function 2x plus 1. Here are the solutions. You are going to copy the given function and then replace f of x with y, and it will become y equals 2x plus 1. Interchange x and y. So replace every x with a y and replace every y with an x. So our equation becomes x is equal to 2y plus 1. Solve for y in terms of x. So we are going to transpose 2y to the other side of the equation and x to the right side of the equation. So it will become negative 2y equals negative x plus 1. Then divide both sides of the equation by negative 2. So our equation becomes y is equal to x minus 1 over 2. And replace y with this notation: f inverse of x equals x minus 1 over 2. Therefore, the inverse of the function 2x plus 1 is x minus 1 over 2. For example number 3, find the inverse of the given function, which is f of x is equal to x minus 2 over 2x plus 3. Now, here are the solutions. Write the given function, which is f of x is equal to x minus 2 over 2x plus 3. Now, replace f of x with y, and it will become y is equal to x minus 2 over 2x plus 3. And after that, interchange x and y. Replace every x with a y and replace every y with an x. And our equation becomes x is equal to y minus 2 over 2y plus 3. So we are going to solve for y in terms of x. So we are going to use the cross multiplication process. So our equation becomes the quantity of 2y plus 3 times x equals the quantity of y minus 2 over 2y plus 3 times the quantity of 2y plus 3. And then we are going to cancel out 2y plus 3 here. Or our equation becomes like this: 2y plus 3 times x is equal to y minus 2 times 2y plus 3 over 2y plus 3. So that is why we cancel them out. Okay? And our equation becomes 2y plus 3 times x equals y minus 2. And simplify them further by distributing x to the two terms 2y and 3. So 2y times x, the answer would be 2xy, plus 3 times x, the answer is 3x equals y minus 2. So our equation becomes, okay, like this: 2xy minus y is equal to negative 3x minus 2, because we have to transpose 3x to the other side of the equation and y to the other side of the equation, because we need to isolate the variable y. After that, we are going to get the common factor of 2xy minus y, and its common factor is y. And then factor it out, and our equation becomes y times the quantity of 2x minus 1 equals negative 3x minus 2. And then after which, we are going to divide both sides of the equation by 2x minus 1. And then cancel 2x minus 1. and the equation becomes y is equal to negative 3x minus 2 over 2x minus 1. So this is considered as simplest form because there are no factors which are common to both numerator and denominator. And after which, we are going to make this y into this notation, which is f inverse of x equals negative 3x minus 2 over 2x minus 1. Therefore, the inverse of f of x equals x minus 2 over 2x plus 3 is f inverse of x equals negative 3x minus 2 over 2x minus 1. So this time, let us have a review regarding the composition of functions. With a given, f of x is equal to x plus 2 and g of x is equal to 3x. Find f circle g of x. We have to identify the outer function which is considered as the main function and the inner function as well. The outer function in the notation f circle g can be found at the left side, which is f. So, f of x is our outer function. And the inner function in the notation f circle g can be found at the right side, which is g. So, g of x is our inner function. So here are the solutions. F circle g of x can be written as f of g of x. Next, place the outer function, which is x plus 2. After that, substitute the variable x with inner function g of x, which is 3x. Then copy plus 2. Then simplify them further and we come up another function, which is f circle g of x equals 3x plus 2. The reason why we have the review of the composition of functions because we will be dealing this time the composition of functions and its inverse. Please consider this composition of functions and its inverse. This is used to verify if the pairs of functions are inverses of each other. A one-to-one function and its inverse have the following properties. First, f inverse circle f of x equals x for all x in the domain of f of x, and f circle f inverse of x equals x for all x in the domain of f inverse of x. So, for example number 1, verify if the given pairs of functions are inverses of each other. With a given, f of x is equal to 2x and f inverse of x is equal to x over 2. So, find f circle f inverse of x. So we have to find, or we have to identify first the outer function, which is considered as the main function, and the inner function as well. The outer function in the notation f circle f inverse can be found at the left side, which is f. So, f of x is our outer function. And the inner function in the notation f circle f inverse can be found at the right side, which is f inverse of x. So, this is our inner function. So, we have to consider this solution. F circle of f inverse of x equals f of f inverse of x. So after that, write the outer function, which is 2x, and then substitute the variable x with the inner function x over 2, and then simplify them further by cancelling out 2 and 2, and our answer will become f circle of f inverse of x equals x. Since we are not yet done, because we have to find f inverse circle f of x, but we have to identify the outer function and the inner function first. The outer function is f inverse of x because it is written at the left side of the notation, and the inner function is f of x because it is written at the right side of the notation. Here are the solutions. F inverse circle f of x can be written as f inverse of f of x. Place the equivalent of our outer function, f inverse of x, which is x over 2. And then substitute the variable x with inner function f of x, which is 2x. Copy over 2. Then simplify them further by cancelling 2 and 2, and we come up another function, which is f inverse circle f of x equals x. Since f circle f inverse of x equals x, and f inverse circle f of x is equal to x, then f of x is equal to 2x, and f inverse of x is equal to x over 2 are inverses of each other. For example number 2, verify if the given pairs of functions are inverses of each other. So we have this given, f of x is equal to 2x plus 1, and f inverse of x is equal to x minus 1 over 2. So this is what we are going to look for. Find f circle f inverse of x, and we have to identify first the outer function and the inner function. The outer function in the notation is f of x, and the inner function in the notation is f inverse of x because it can be found at the right side. Here are the solutions. F circle f inverse of x can be written as f of f inverse of x. Place the outer function, which is 2x plus 1. After that, substitute the variable x with the inner function f inverse of x, which is x minus 1 over 2. And then cancel 2 and 2, simplify them further, and it will become x minus 1 plus 1. And the f circle f inverse of x is equal to x. So we are not yet done because we have to look for f inverse circle f of x. We have to identify first the outer function and the inner function. The outer function is f inverse of x because it is written at the left side, and the inner function is f of x because it is written at the right side of the notation. Here are the solutions. F inverse circle f of x is equal to f inverse of f of x. Place the equivalent of our outer function, f inverse of x, which is x minus 1 over 2. And then substitute the variable x with inner function f of x, which is 2x plus 1 minus 1 over 2. And then simplify them further. 2x plus 1 minus 1, it will become 2x over 2. So 2 divided by 2, the answer would be x, and our function will become f inverse circle of f of x equals x. Since f circle f inverse of x is equal to x and f inverse circle of f of x is equal to x, then f of x is equal to 2x and f inverse of x is equal to x over 2 are inverses of each other.